Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. This session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenters to answer. I'll now turn it over to our speakers for today. Thank you, and let's welcome him here, Bruno and John.
Good morning.
Hey, Don, hello, and hello, everyone. I see a couple of familiar faces here in the Reactor and a couple of new people that are excited to know more. There's somewhere we have here that, hey, let's make voice agents and more. And hey, let us know where are you joining from. It's been a while since I am doing Reactor sessions in English and more, but hey, hello, everyone. I'm super happy to be here with Don. Don, please, can you introduce yourself? Tell everybody who you are.
Sure, thanks, Bruno. So I'm Don Chenard, I work for NVIDIA. And Bruno and I have put together a little presentation for you today that I hope you feel you got a lot out of. What we're going to do is we're going to build a voice-enabled AI agent. So that was very clear in the title, and we're going to deliver on that. I'll be presenting the concepts that you need to have in your mind so that you can fully understand what Bruno will fluently be on the keyboard, making happen for you. So you're going to get two passes at it, right? For me, you'll get framed in, and then Bruno's going to take you right through. So there's 5 sections to the presentation. The first is just a quick introduction to the Azure platform. Then introduction to the NVIDIA technologies that run on that platform. And then you will get right into the code, which is a speech AI demo that will be run locally, where the model is downloaded and run locally. And then we'll take that same model, run that up in Azure. It's another way you can go, right? You're going to want to see it deployed in Azure for sure. And then it turns out the easiest way to run and deploy models is with this thing called NIM, which I'll explain in a minute. And Bruno's going to use at the very end, okay?
Yes, and hey, before we start, John, just for the people who are new here or don't know me and more, this was an amazing learning experience for me. I like to learn. By the way, say hello, every people from Canada, Portugal, Toronto, Philly, the States, India, Jose from Switzerland, and more. We have a lot of people here and there, but when we started to do this, and I was trying to learn how we move myself around in the NVIDIA ecosystem, it is crazy good. Literally, last week, I set up everything. I think we arrived from, can't remember, mid last week, and I said, John, I have everything already cooked. He's happy with this and more. And I started to talk about this. And he told me, have you heard about NIM? No, what's that? Welcome to NIM for Bruno, and added, makes sense, is part of it's something amazing. So I'm super excited here to share this with you. Please keep the questions and more coming. I see people from India, from Italy, Nigeria, and more, because this is all a learning experience. And as we are sharing today, everything, all of I think the entry point here is in build.nvidia.com. This is where you're going to find everything that you need. So we are not going to be able to cover all of the stuff that we want to do because there are so much, but that's the entry point for everything. And as usual, we try to answer the question live. I'm happy to connect later and do more. And hey, I'm super excited to start. So back to you, Don. Sorry, I was just trying to set up the context because this is great.
Fantastic. Thanks, Bruno. So without further ado, what I've done, I spent a lot of time, folks, on this slide. This is for you, and it took a lot of time. And this lays it all out for you. Each one of these is a link. Okay, and what you want to do is go to every one of these links and read what's there. And once you've done that, you will be a master of all of the information that you need to know. So this is your table of contents for developing agents on Azure using NVIDIA technologies. There's really 5 different phases to developing an agent, right? First thing is you're going to need some development tools. to build apps or just to build agents, whatever you happen to be doing. And then beyond development tools, you're going to need to have a data strategy, because as it is often said in AI, the most important thing is your data. Garbage in, garbage out. You need to have a solid data strategy. And once you've got that in place, you can take that data and use it to train models or to create models or to inform models so that they're more grounded. And so that's your model selection. And there's hundreds, there's thousands of models out there. And then you can customize them for your particular use. We'll talk about that. And then you've got it all set. And you're going to deploy. And so here are the technologies from Azure and from NVIDIA that help you with your deployment. And then lastly, once it's deployed, you need to operate it, make sure it's running securely and things like that. And so those are the technologies in the far right column for that. So I'm going to assume you already know the Azure. Okay, so it's like your tools are GitHub Copilot, Visual Studio Code, and Copilot Studio. You live in that every day. What I'm going to encourage you to do is go take a look at these NVIDIA blueprints. They don't just use one model. They have multiple models being used together to achieve that particular blueprint. I'll talk more about those in a minute. And the NeMo agent toolkit is another thing. And you might think, oh no, wait a minute, Microsoft gave me something for agents. They do different things. Okay, you want both. Then for your data strategy, you've got Microsoft Fabric, you've got Azure databases, all kinds of richness up there. And then what NVIDIA brings is NeMo Curator helps you kind of groom data that you've taken in so that you can get really good, high quality curated data. And then if there isn't enough data, you can make up your own. You can use Data Designer to create synthetic data, or you may have gotten some synthetic data that needs to be worked over a little bit more. And so the Data Designer and Data Synthesizer, a Safe Synthesizer, do those things. And lastly, we've got these technologies, NeMo Retriever, that help you build RAG style applications to go ahead and access the data at runtime. For model selection and customization, it's Microsoft Foundry's where you live. You got models, tools, and Azure machine learning up there. NVIDIA's real big on Nemotron. Now, these are open source models that I'll tell you about. Evaluator, because there's hundreds and thousands of models. You need to compare one against the other, and we give you a tool. Microsoft has tools for that, but we give you tools for like over 100 academic benchmarks and different evaluation jobs that you can set up. So it's complementary. And then NCG is our hub where you find all kinds of things. It's like kind of like going Hugging Face, right? But it's like the NVIDIA stop. For deployment, you're deploying on Azure AI Infrastructure, AKS, Azure Container Apps, or Azure App Service. What NVIDIA is bringing are NeMo microservices. Our full suite of software is called NVIDIA AI Enterprise. Run AI is a better way to command Kubernetes, and Dynamo is the latest inference server technology. And then lastly, for safety, you've got Azure Content Safety. No one moves until they log into Enter ID. And once you do that, I'm going to determine what I will and will not let you get to, right? And since you don't want to chase all these keys around, you can just use managed identities. It's going to be a lot easier. You've got Microsoft Defender, you've got Azure Monitor. And then NVIDIA brings to the party our NeMo guardrails and our auditor technology. So there you go. There's a lot of technologies to use, and every one of these clicks, it's going to take you, half an hour to read. So there's a lot of studying all teed up here. And I'm only going to talk about things that are on this slide now and expand them slightly before I hand off to Bruno. So, and I'm going to go.
Sorry to interrupt. We have a couple of questions here, and they're interesting.
Questions, but what do you got? All right.
Yes. So first of all, everybody wants the links of that slide and more. So what I am going to do is I am going to add all of the links and the slides in the repo, in the repository that we are going to share. So you have everything there. And there is a super nice question somewhere here. I'm sorry, there are a lot of them, but when we share the repo, I am going to share this slide with the 20+ links that we have here, so you can go, because yes, it's hard to read here. But there is also a super important question here about, someone asked about the NeMo agent toolkit. can it lead with the other, like an example in Microsoft, we have the agent framework, and the short answer is yes. Agent Toolkit supports A2A, the agent to agent specification, agent framework supports A2A. So if you can create agent with any of these frameworks, you can connect them, you can orchestrate them later. Right now, we don't have that as part of the session, but I will spend some time, I will create something, and I will share it later with all of this. So this is something that, as I said,
I'll cover the subject a little bit too.
Yes,
so
it's part of what we're going to see, but hey, thanks for the questions and more. I'm happy to also help there. And yes, this is an amazing slide, by the way. This is the entry point for a lot of stuff. Sorry, Don, back to you.
Okay. Yeah, I'm not big on a bunch of marketing fluff all over the place. I'm like, no. Complete, concise, thought through that I can use. So that's kind of the emphasis here. Okay, now, when it comes to NVIDIA Nemotron, it's not just models. Okay, we do have models that do, some of them are reasoning, a lot of them are reasoning models. Some of them have visual understanding as well as, the understanding of words. There are models specific to speech, which we'll be using here today, and for RAG and for safety and so forth. So with Nemotron, what we have is a collection, looking at the bottom of the slide, we have a collection of open models. Now, some of them we'll take like a llama and make it better and then put it out as llama Nemotron. But it's a lot of, but the optimization really pays off. It makes it run more cost effectively. It can actually be more accurate too. Then there's models that we just do straight up. We've got huge research departments, and so we build models. We're world-class model builders now, and that's Nemotron. As you're seeing here on the slide, Nemotron Nano 29B. That's just like all NVIDIA. Very nice model. And now, not only do we put out the open models, but the weights are out there. So you've got everything, the source and all the weights. And very important, the data sets. We have open data sets, whether you're using them with our models or using them with something else, it's an open data set. You can come and get it, a whole bunch of tools and techniques and research. So we're very, very open because, in the end, we're going to run this on our GPUs and we're going to make money on that. So we want the whole industry to proceed forward as fast and as strong as possible for delivering value to humans, and then we'll sell more GPUs to service those humans, right? So now when it comes to the Nano 2 model, it did achieve the highest reasoning accuracy among small models. So reasoning accuracy, let's just go with the second column in here. You see GPQA Diamond, that's scientific reasoning, and you can see Llama Nemotron Nano 8B, and then Qwen 3 8B, and then the highest score goes to Nano 290. Okay, and all these benchmarks are doing great. You can see the benchmarks at the bottom of the slide. Read it when you get a chance. But today we'll be focusing on two models that are industry leading. It turns out the best speech models in the world come from NVIDIA. So heck, if you're building an agent, a speech-enabled agent, why not use one of these models? So we've got, this is a leaderboard here, a Hugging Face leaderboard. And you can see Parakeet right up there at the top. You can see another one, Canary. Those are the two that Bruno's going to be using. Here's a whole bunch listed here. Now, when it comes to use cases, people use our Nemotron technology certainly to do things with speech, but which is kind of the Riva stuff and the Parakeet and Canary stuff. But it also used for just doing an app that might be doing reasoning, some sort of agentic reasoning, where you need to break a problem down into components. You need to think about what's happening, try different strategies, be proactive, use tools, use data sources, to come up with so you need an orchestrator, you need a thinking model, a reasoning model. And so we've got a bunch of those. Then there's vision language models. So you can do like video summarization, things like that. Information retrieval is kind of the meat and potatoes of the industry right now. You want to show an ROI for AI? Build a chatbot. Right? Just build a chatbot that serves grounded information, right? Based on, your documents for your organization. And that chatbot does what? It either makes your end customers happier, or it makes your internal people more productive and happier. So you can outmaneuver your competition, make more money, and have your business run better. And then there's technology specifically for content safety, and then there's all the data sets. Keep it moving here. Now, if you go into now remember, the center of the world's Azure, right? So that's where you live. You're not leaving that planet. You're living on planet Azure. You're on a good planet. It's human, hospitable. That's a place to be. And here I'm in Microsoft Foundry, just a screenshot, and looking at the model catalog, and someone had started typing in NIM. So these are some NIMs. I think later you'll see Bruno type in speech, and you'll see that these models, you can get them from a number of places. One of the places is right in the Azure Marketplace. And so the building blocks for agentic AI is a lot more than just, and NVIDIA has some models, let me look into that. Because as I mentioned, we've got blueprints. Maybe you're doing a research assistant. These are pretty complex. I should have given you a blueprint so you can see. They're quite detailed. But just go to our website, you'll see. So maybe you're building a research assistant, maybe you're doing a customer service agent, or a software security, something in software that's going to automate some aspect of software development, what have you. So we have blueprints for all of these major areas. And then our tools, I mentioned on that first slide with all the links. These are the NeMo tools: Curator, Customizer, Evaluator, Guardrails, and Retriever. So take a look at those. And then if you want to run any models that you've customized easily, that's where NIM comes in. And we've got NIM for all of these different use cases and more. So you can go ahead and do multimodal RAG, or discover new drugs, or do vulnerability analysis, or do visual search and summarization. You're not starting with a blank piece of paper. You're starting with an architecture. Feel free to, substitute out parts and expand as necessary, but we give you a good starting place. And you get all the, not only the diagrams, you get the source code and everything that goes with it. So for a long time, people have used this NeMo framework. This is pretty much a staple. If you're doing AI, you're probably using the NeMo framework because it works on open source libraries and gives you fine-grained control over training the models, supervised fine-tuning or reinforcement learning, different techniques. On top of that, here they are: data designer, synthesizer, customizer, evaluator, guardrails. See, these are services that we built for you that you've been hearing about through this presentation. And those services you're going to use when you build an AI application. Just crank these up. They're NIM. So just crank it up and use it as part of your overall application. Now, let's say you're doing an agent. Microsoft has excellent tools for you when you're building agents, but so is the NeMo Agent Toolkit. And you'll find that we're way down in there, like optimizing the running of it on our GPUs. And Microsoft's like, yeah, let's let NVIDIA do that part, okay? Microsoft's up looking across where they should be. And we're like way down in scheduling stuff on the cores of our GPUs. So it's a better together thing. Now NIM. Let me explain what NIM are. NIM are Docker containers. So it's a portable container that contains a model that you want to run and contains everything you need to run that model. It's all in the NIM. So you know how containers are, Docker containers. You can run them local, or you can run them up in a cloud. That's the nice thing, is they're portable, they're easy to deploy, easy to use. And when this, and so what we put in the container is very, very optimized. We have a whole team, a model doesn't just go in and out the door it goes. Massive optimization and engineering work goes in to make sure that these NIM run like a fine Swiss watch, if you will. Now, once the NIM is stood up, once the container is stood up and you want to use it, it has exposed itself at an endpoint. See the very first thing? industry standard APIs. You're going to come in and you're going to use now this model. If you're just going to do regular LLM stuff, why not just make calls that look just like OpenAI calls? Why vary? Yeah, they set the API, so our NIM come up, and it's like, hey, it's like OpenAI came up. What's your question? What's your prompt? Now, in other areas, maybe where we're venturing into new territory, the API might be a little bit more extensive. Now, when you bring the model up, you need to bring it up on an inference server. And the kind of the industry standard open source inference server is Triton. So the NIM, what happens is when the NIM's being stood up, the model is investigated, and depending on how the model was made, the correct inference server will be used to stand up the model. Okay. Now, if you're building a model and you want it to be optimized, then you're going to use TensorRT. Think of it as a compiler and a runtime that makes your model really run well. And if your model is not just a general model, but in particular is a large language model, billions of parameters, oh boy, those are new challenges. And so that's where you step up to TRT-LLM, TensorRT-LLM. And that library is specifically for doing large language models. And then you've got the other things in there, components are in the container for doing enterprise management. And that's going to talk through Kubernetes, because containers run on Kubernetes, right? Then that's going to talk CUDA down to the actual hardware. Okay, so there's your intro to NIM. Pretty tight, all on one slide. I hope NIM are not confused. The Docker container, totally optimized, runs great, exposes itself as an OpenAI compliant endpoint. Couldn't be easier. And so, number of things you could be doing, look across the top, all those logos. I'm running out of time and I'm not going to read them. But in all of these areas, either Microsoft Research or our partners are doing stuff. So there are, top of the slide, 170 plus NIM, okay, 40 plus model types, lots of partners. And these, they just come right up because they're containers, whether it's on a VM. If you're going to go with Azure N series for your for your hardware infrastructure, then you're just going to use our image, use our VMI, okay, because it's got everything in it that you need, and you can run on that. Or you can go ahead and use Azure Machine Learning. Our NIM work with Microsoft Foundry, works with ACA, works with AKS to answer those questions. And so with that. Oh, gee, I'm almost right on time, Bruno. This is amazing. So with the things that I've covered, and I've only, covered the surface of it, I've tried to, keep it fairly tight. Your next thing, other than going to the links on that first slide, is just go ahead and go to learn.nvidia.com to learn more about these things. And because you will be using Azure as your primary platform and using NVIDIA technologies on there, you're going to want to also join our developer program so you can hear about the NVIDIA part of that. And so that's it for my section. And with that, Bruno, take it away. Let's fulfill the promise and build this speech agent.
Yes, and by the way, I have a couple of questions here. So while I am sharing my screen, give me a second and let's switch slides and more. While I'm sharing my screen, let me go back to those questions that this is a great idea to have office hours on Discord after this session. Let me bring this back to the team. I mean, initially, I know that we have office hours for the Python series and the .NET series and more. So let me see if we can also have office hour on Discord. I will go back here and try to figure out if we can do it or not. Then I have another questions around that. The models available in Foundry right now. Yes, I'm going to show this right now. I'm going to show what we have in Foundry, how you can navigate NVIDIA models in Foundry, and then how you can start local and move to the cloud, which is kind of the idea that we have right now. And I am going to jump to the other questions, and we're going to try to show everything. But this is how we are going to do, and this is what we literally talk right now. Start local with a couple of models local, and then move to the cloud. And in the meantime, explain all of the libraries, the inference capabilities, inference platform, NIMs, and more that we have right now. So It's not a very, very, very complicated scenario, but I think it's good enough to understand what we have. So first of all, links, we have tons of material here. But if you are developing this, the library that you need to learn is NeMo. Literally, I didn't know that. I learned that in the last couple of weeks or month or so, and it's an amazing one. It's give you, for this specific scenario, it's give you a level of abstractions that is very, very good. And as Don mentioned, it's also optimized. So it works great with your model, in your GPU, or even in the cloud. So it's great to do that. It's fully documented. You can do amazing things. And for this scenario, people who know me knows I have a podcast, and I have also automated most of the part of my podcast where the only thing that I do is talk there. But then I was trying to figure out a way. It's okay, once I finish my podcast, I want to automatically generate a transcription of the podcast. That's where I get to the speech ASR, automatic speech recognition models, the Parakeet, and then the Canary, and there are others there. You have the small ones and you have the big ones. It's very, very cool. So give it a try and take a look. And how I get here. So this is the part of how we are working today. Most of the people, my colleagues here at Microsoft, of course, we use Copilot. And of course, today what we use is literally, and by the way, this is the last slide before I switch, is literally, hey, I want to use Copilot, but in the model that I am working more comfortable right now. So if I am already in a project and I am already in a solution, working in a team, a published repo with colleagues and more, my tool will probably be Visual Studio or Visual Studio Code, and then I'm going to share and work there. But for learning stuff, I'm a very big fan today, literally very big fan of Copilot CLI. Because in Copilot CLI, I can do stuff very, very easily like this. So let me go here to my screen, and I can go to Copilot. Let me open Copilot. I'm here in the sample folder, and we have a Copilot, banner. So I'm going to start Copilot CLI, and then I am going, when I have this super cool and nice animation, I am going to ask a question to Copilot, and I have here, literally, I want to create a short Python script that will generate a transcript from an audio file. I want to use NVIDIA Parakeet, and let's start with the smallest model that we have. So I am going to ask Copilot to create this, but the way that we work, and this is important, and someone was asking about this, I am not going to ask Copilot to write the code per se. I am going to switch here between different modes, and I am going to basically switch from agent mode, which is literally work like that, to plan mode. Why? Because I want to create a plan first. And when I do this, Copilot will start. I'm using the Cloud Opus model. And someone asked a question in the chat about how we use big models, small models, and more, how we work locally versus the cloud. There is a mix here of stuff that you can do locally, and then when you need kind of the big guns, you can switch to the cloud. So an example, to make a plan where you see that this Cloud Opus 4.6 is searching the official documentation, searching the plan Parakeet, it's doing a lot of stuff. This is the good moment to use a big model. But then for the implementation, let's do this. And I am creating a plan. So Copilot is going to say, okay, what do you want to do? Do you want to create a console-only application? Do you want to create an application that is going to do text and timestamp or just save? I'm going to say, hey, plain text only. That's the only thing that I need. And then it's going to think a little more. Probably it's going to ask me, okay, do you want to do A, B, C? The plan will take some time. This is the model basically analyzing. This is a Copilot agent using a model to analyze how is the best word to use with Parakeet in this specific scenario. And then after that, Anna is going to basically create a plan, and the plan will be create a script. This is the name of the script that use this model, and then do CLI and convert audio to file. So it's going to start to do this. The way that it's going to work, if I go back here and I go for Shift Tab and I'm going to do Start, this is going to start implementation. So I'm going to leave it here. Because it's going to take some time, I am going to save parts of that time. Let me minimize this. This is the repo that we are going to share, that I'm going to ask Clarissa to share the repo. And by the way, as soon as we finish, I am going to add slides and all of the links in the repo so everybody have it. But what I want to, and this is what I like. You know me that I am a programmer, and I like simple things. So this is the ABC of how we can use NeMo with Parakeet in a standard Python application, in a console application. So of course, the first step is going to be, let's read an audio file. And later we are going to, there are a lot of blueprints. In example, if you go to NVIDIA, I'm going to show it right now, NVIDIA, and if you want to do streaming or if you want to do kind of a real-time audio, you have specific scenarios covered to do this. But in a simple console application that receive an audio file and generate the transcript, of course, first step is read the name of the file. Then, because this model require to use a WAV file that is going to use 16 kilohertz, it's a specific format for this, we are going to use Librosa and Soundfile, which are two libraries to do this, that convert that MP3 or whatever other file to this format. By the way, this is all came via Copilot, via the documentation from Parakeet, which is amazing, we have there. And then step 3 is, let's load the model. This is where the inference starts. So I am going to load the model, and you see here that I am going to load kind of a small, quoting small. A small is probably depend on your GPU, your capabilities, and more, but this is kind of a small model, good to start. An NVIDIA Parakeet 0.6 billion V2. And I think the V3 is already there. While are we doing this? And I started to realize there are other models, other versions. This is great. So once we have this, we are going to ask the model, okay, hey, model, start the transcribe. Pick up the audio file that we have, include the timestamps, and create an output text there and show it in the console. Or no, this one is going to save it to the disk in the output folder there. And that's it. That's as easy as 1, 2, 3. Get your file, convert the file to the right format, load the memory, load the model in memory, and ask the model to transcribe. So this is cool. And of course, if you know me, I like to show stuff. So let me go here and let me also show you. Let's do here. This is also a vibe code version of a GPU monitor. So this is what you see at the left is basically my GPU working. And I'm here in the scenario 1 where I'm going to do Python, simple transcribe, and I have here a small file, which is called 26 January 30, and it's a 30-second audio of a live stream. When I start this, it's going to take some time. We are going to start to see that first is going to convert the file to WAV, and then it's going to start to load the model in memory. Where is this? Okay, sorry, I scrolled down. So it's going to convert the file first to the specific format, then it's going to start to load the model in memory, and after a couple of seconds, there it is. And there is a lot of logs and warnings that I enable to basically understand that we are doing. But after a couple of seconds, let me scroll back here. The model is in memory. We are going to start to see some spikes in the CPU viewers, and then we have here the transcription. Hello everyone, Bruno here, and that's basically what we have here. Super easy, and just to show you, this is my GPU working. But I like consoles. Everybody likes console, and because we were talking about Copilot CLI, a colleague created that some time ago, and I updated with more. But this is again as simple as it can be. Load the model in memory using NeMo, and then start to use the model to do the transcriptions. And if you want to know more about these models, and yes, we talk about this is in Azure, let me go back to Foundry. Let me go here. And by the way, this is the entry place that if you want to start, this is the entry place for me to learn a lot of things. Build NVIDIA.com, that will also help you to go to developer NVIDIA. I think it's developer NVIDIA.com, Don. I can't remember. I switched for, and then you also have the api.nvidia.com and more. And someone was asking if the labs are free and more. I don't know, but when you create a developer account in NVIDIA, you have access to a lot of things. I really don't know the details. We can probably do a deep dive there later, but you have a lot of free resources to test, to do labs, and more. But how do I get here? I started in Azure, in Foundry. Oh my God, I need to reload again. Yes, I started in Foundry, and when I went to our model catalog and I started to do some speech. No, I think the first time that I want to do this, I went here to the type of stats that we have, and I filter by ASR. And as you see here, when you filter by ASR, you have a lot of NVIDIA models here, and you have a Parakeet. I don't know what is the TDT CTC 110 megabytes, probably smaller or big one. I don't know. The cool thing about this is that everything is super well documented. If you pick up, let's pick up the first one. If you pick up the model, as you can expect in Foundry, you have here the chance to use this model, so you can deploy this and you can use it later, and literally everything's happening there. And when you deploy the model, you are going to see a lot of samples, how to use it and more, and the model card will redirect you, in this case, to the NVIDIA org in Hugging Face with all of the details of this specific model. So it's all literally super easy to start. This is how I started to do, and my idea was, let's start local, and let's start to do this in a way that we can literally start to use this model, because I will assume that everybody knows Hugging Face, everybody knows NVIDIA, and everybody knows Foundry. So we are mixing all together, and it's great because you can start with this model here and later deploy it to the cloud. And I am going to go back to some of the questions here. I see that take this as feedback for demo show code. At least Bruno did that, so I am good. Oh yes, I am all about code, man. This is, you know me. I like to show code. I like to show the stuff that we are doing and more. So yes, we have more code. Hey, as remember that we start locally and when to start to move to the cloud. So when I was working with Parakeet, something that I learned is that Parakeet is amazing, but it's only English. So it worked great with English. If I use Parakeet with one of my Spanish audio in podcast, iFace basically said, no, Parakeet is not for you. Then but there is, of course, there is another model to help you there, which is the family of Canary models. Somewhere here we have in the, let me maximize this, and somewhere here in the scenarios that we have, by the way, I haven't talked about where you can find all of this. This is all part of this repo, where you can start to see this transition toolkit with different scenarios, simple CLI with a menu, multilingual, and a client server, which is the goal at the end to deploy to the cloud. But this is how you can start. It's all Python. I think that Larissa shared the link. So this is where I am going to later add the slides and all of the resources. But then I get to a point where, as I said, I try to start to do some transcript using Parakeet in Spanish. And no, Parakeet is good for English only, but for multilingual scenarios, there is the Canary, and there are other models. I can't remember the name. I don't know, Don, if when we were talking, I know that there are other models, can't remember the name, but that's where you should go here. Yes, you have this NVIDIA Catalog Explore, and you start to search. This is the good place to do, NVIDIA catalog.nvidia.com. This is the good place, yes? Yeah. I think so. So yeah. When I was here, as I said, I have this other scenario. Let's clear this. There it is. And let's go to scenario 3, where I can't remember the name of the file here. It's called transcribe. And I have here a couple of audios in English, a couple of audios, sorry, in Spanish, in English, and then my Python file, again, all created with Copilot. And then I clean it up a little. But what I can do here, it's something like Python transcribe, and this by default is going to show me a couple of, when we are doing command line application, please add help to your command line application. So in this one, we need to define the audio file that we want to use, the language code, the model. By default is going to be Canary 1B, and then you have the model that are supported by this script. If you want to take a look at the script, by the way, it's all in the repo. It's not very, very complicated. As I said, I try to clean it up a lot for people who can read and learn how to use it. And this is where you import a couple of files, and then you have the list of files. This is all for the help. And then you start to have, again, you need to convert usually the MP3 to the right format of the file. Then for the timestamp, there are specific conversion that you need to do. You know how crazy are time and time formats when you work with this. And then the other part is, let me go here, generate, print help. And if we go to the main, this is the ABC of receive default, where we are going to load the model. There it is, load the model. And then when we have the model, load the model. When we have the model, first of all, we load the libraries. And then we load the model, and then we do model transcribe. And that's literally it. So it's not tricky at all. It's what we've seen, but this file is more documented, it's more created to do more stuff. So if I run this again with my, let's do this like this. So if I run this again let's do Python transcribe, and I have NTN. This is one Spanish document, so this is going to start to do the same process as we see before, and at some moment where, by the way, the first time that you run this, the model locally will be downloaded, so that's a gigabyte or more, depending on the model, but they are not so big. But once you have this, the first is going to be stored in your cache, so you don't need to do that every time. And after a couple of seconds, it's going to load the model in memory, and it's going to start to generate the transcribe again. So ABC that you can repeat a lot of times. And it's not very complicated. And it's also, there are a lot of options in the NeMo libraries that you can use to do more. But there is a moment, I think, that everybody wants to, okay, I want to do this. I want to run this, in example, in a server, because I want to have a server, and there it is. That's the model starting the transcription. I want to run this in a server because I want to, and once I think it took longer to load the model in memory than literally to do the transcription. These models are so good. They are so well optimized that you have everything there. It's amazing. I really love a lot learning all of this. But moving to the web part, we have the application, we have the model, we have the libraries, the NeMo, and then I created literally what we usually do. I created the web server that has an endpoint that you can call, and it's going to start to do the transcription there, using Flask, doing NeMo, and more. And this is the last scenario that we have here, where, let me minimize this. So in the scenario number 4, what we have is a client where we have basically the client application, and we have the server, and the server is a Flask application that is going to to load the model and more. And you see here a couple of Hugging Face and a couple of Hugging Face Hub and more. I'm going to get there soon. But this is a Flask application loading the model and exposing an endpoint so you can do the transcript with the model. For the front end, I have a Blazor application, and it's all orchestrated by Aspire. If you don't know Aspire, Aspire is a technology that we have it's a platform/tool. It's not easy to explain, but the whole idea here is that Aspire allows me to, in example, define these resources. In this case, I am going to load the API server, which is going to be a Docker container running my model in memory. And you see here that I can define the image that I want to have, the health checks, and more. And then I am going to run a NIM server. I'm going to explain this later. And then I will have the front end that is going to have reference for both of those services. And the front end is a web application. So if I run this, what we are going to have is something like this. Scenario 4. And I will do Aspire run. And Aspire run is going to basically start the full orchestration. And out of the box, Aspire will manage and will get all of the traces and logs and service discovery. It's going to manage all of those services out of the box for us. And if I open this URL, what we are going to have here is that we have the waiting models, and we have also the API server and the NIM running. This is probably going to take some time. So what I am going to do, it's start to build and more. So what I am going to do, because first time is going to take some time to load everything, let me show you a 2-minute video of this running. So this is Aspire, as I showed you before. This is running, and once the model, when the host is loading and starting all of the services, I am going to start to open again the URL, and there it is. It's already running, and you can take a look here. This is the NIM server, and you can see this has been running for a while. And at the beginning, it's basically show that this is an out-of-the-box inference servers that we have from NVIDIA. And I'm going to explain this later, but I want to show you that we have 2 backends here. One custom-made by myself, and the second one doing with NIM. This is the custom-made. This is the Flask application here. And this is the one that is going to load the ACR automatic speech recognition models, and is going to expose a front end for this. If you take a look at how this is organized, so we have a web client that is calling the API server and also is calling the LLM. The cool part about this is that, hey, this is how it works. I'm sorry I am not a designer, so I am not very good with UIs and more. So sorry. But you can select the file here. I'm going to drag and drop here one of the sample MP3 files that we have. And then you can do more, like in example, configure it, say, okay, which model do you want to use? Parakeet, generate timestamp on more, and then start the transcriptions. It's going to take some time the first time because it's going to load the model on memory. And the cool part about this is that when you start to do your own inference servers, you can learn a lot about how you load the model in memory, if you want to cache that model, if you want to kind of reuse the model. There are a lot of good options here. If we take a look here, that's waving line. This is the amazing CUDA showing us, hey, I am loading the model in memory. Now you have all available for you, the model to be run there. And as you see there, that's a transcription. Hey, hello everyone, Bruno here, if you want to follow my blog. So this is one of the demos that we have. But this is the moment, let me stop the video. This is the moment where last week, talking with Don, I realized that we can do better here. I realized that I completely missed this, but as part of the documentation, we have NIM. And Don has already explained what is NIM. And NIM are out of the box, literally, containers, definition of containers that you can use, and they are enterprise ready to be used, but you can run locally, and then you can run it in the cloud. So you can pick up a model, like in example, this Llama 3.2, 3B. This is kind of, again, small model. And then when you are logged with your account in the developer portal and more, you can get the container here. So you can access and download the container and create an image. So I was thinking, okay, what else we can do? How we can move forward here? Instead of me writing all of the inference servers code, let's use this pre-packaged enterprise level, and for sure created the people who are much more intelligent than myself, which are ready to use. So this is the other model that you've seen here, the NIM model. And I was thinking, hey, I already have a transcript generated model there. Let's do something else. Once I have the transcript, I want to use, in this case, Llama 3.2, and I have a very small prompt that is going to say, hey, this is the full transcript of the podcast. Analyze this and suggest me a title, suggest me some keywords, and also a description to publish this. So with this, what I have, let me show you the other demo. This is the other demo, which is basically the same, but instead of generating the transcript, I am going to paste here the transcript. I already have a couple in the output. I already have a couple in the repository, so can't remember which one I pick. Probably the big one. Yes, not the 30 seconds. This is a full episode because, hey, these are super good inference servers here. So I'm going to pick up the transcript and I am going to paste the transcript there. And I'm going to ask, in this case, a Llama 3.2 model hosted by one of these NIM containers to start to do the magic. As you see here, loading the model again in memory, but this is the NIM server doing that. And after a couple of seconds, I will going to have the full info here. The missing piece, let's wait, I think it's a 1 minute video. The missing piece here is, okay, how can I deploy this to Azure? And this is the interesting part. Every time that we deploy models like this in Azure, we are using NIM. And so I'm going to show you one. So we are using these templates also to deploy to the model in Azure. This is the output where you can see that episode was a video. I was talking about extending model MCP apps with interactive UIs. Oh, sorry. Let me go back here. Extending UIs. So, and then I have the description and I have some tags and more. And this is all, again, running locally. But instead of me writing all of the inference for the model and more, I'm using one of the NIM containers that we have. And as I said, the last part is how we can deploy this, how you can have everything ready to be used on the cloud. So there are a couple of options. Of course, one of the options is to go one of these models that I have here in the catalog. And this is one of the Nemotron models, which I am a very big fan. And when you deploy these models to Azure, as we see here in the bottom, is going to use one of the latest NIM definition that was created end of September, yes, last year. And every time that we have new NIM updates and more, there is also going to be updates here. This is correct, Don. Is this correct? that we
Yeah,
have
it's nice to know it's nice to know that if bugs have been reported against a runtime that you're depending on, we're going to send you a notice and say, hey, there were problems, they're fixed, here's the new bits. So
yes, so this is a good question also. What is the naming container exactly doing? I didn't understand how it's working. So the NIM container, and by the way, NIM is not just a container. This is a full set of tools that you can use. The one that I use, it's a pre-packaged image. It's a container that knows how to download the model. So you have NIM, for an example, the one that I am doing right now, it's Llama 3.2, which is a super popular model. But this model is going to, this container is going to, when you start the container, download the model and set up a web endpoint that you can use to later basically use that model. So all of the inference tasks are going to be managed by NIM. And as you've seen in my demos, when I start to do the transcribe and more, there are a lot of logs and there are, I don't know, there are a lot of messages that said, you need to optimize your ABCs, you need to use this token quantification, whatever, and more. NIM is going to do everything for that for you. So it's already ready to be used in the best way possible because, and this is the part I am going to ask Don to explain a little, I am using this with my developer account in NVIDIA, which is, by the way, it's a free account that you can create there, but NIM is also ready to be used at enterprise level. That is correct, Don, yes?
Yeah, our policy as a company is to keep things open source as much as possible and for them to be free for developers to play with. Now, in the case of NIM, if you're going to do a big time commercial deployment, you're probably going to do it with NIM.
Yes.
And at that point, you don't want to be on your own. You want enterprise class support, where if anything happens, it's like, boom, we're going to spring into action and take care of it with enterprise class support. So that's where NVIDIA AI Enterprise comes in. You pay for a license for the enterprise class support. But just to look at something and kick the tires and play around with it, just join the developer program and everything should be pretty much accessible to you there.
Yes, and that's what I also found and I really like a lot. So when you join the developer program, someone asking about if we have access to labs. I started a couple of labs. And by the way, I joined the developer program literally to test this. I used don't spam me, please. This is my personal crappy email for doing labs and more because I didn't want to use the Microsoft one in case we have an agreement so I can access some more stuff. I will say, okay, I will try to use this like someone else, which is still me. But I have a lot of access here to resources and more. In example, you can't access to these containers if you are not logging to the container registry from NVIDIA that you need to do when you are here and you have somewhere here, I can't remember where you have your, somewhere here you have your, I don't want to click a lot to not share personal information, but you have your API keys. When you have your API keys, that keys, you need to use it to download these images. But you can do this for free as part of the developer program, which is super, super nice. So give it a try because the last step here, and by the way, it's part here of scenario 4 in the documentations. I have somewhere here. If you want to run this in Azure, and I have it running in Azure, but I want to go back to the question quickly. Once you have everything set up, this is a container app running on the cloud, running on our amazing services in Azure that they are going to also use the amazing GPUs for NVIDIA. So the only thing that you need to do is the standard, if you are new to Azure, this is the standard ABC. Create a resource group. We are using Application Insights. I'm a big fan of Application Insights to monitor. This is an optional step, but if you have an Application Insights and Azure Monitor, you are going to be able to trace everything there. So optional, but it's still there. Then create a container registry, and then build and push everything. That's it. It's going to push, and you're going to be able to run as option one to run your own inference service on the cloud. If you want to go faster, pick up a model from Foundry, like I pick here Nemotron, use this model, and then deploy it to Azure. I'm not going to deploy it. I already have a couple of them there, but this is even faster. And then you are going to have the same as we've seen before. It's going to be the NIM container on the cloud, but on top of that, you're going to have all of our security features, all of our traceability features, scalability, and more. So there are so many options that as a developer, I like because you can start, as we see before, start local and start to grow. And when you understand, when you have a kind of a MVP or a good scenario, you can move to the cloud and start to grow there. And probably instead of working with the Nemotron Nano, you work with a big Nemotron, whatever. I know that you have very, very big models somewhere there, and I try to deploy a couple of them, and I have some warnings that your manager is not going to be happy if you deploy this, but this is a big one model for that. But hey, if you want big guns, if you want the big power there, you have it there, and I really, really like it. So let me go back to the questions here. Someone
Some bigger models coming, and the really huge ones, they're still training.
Yeah. And someone asked GPU with 6 GB low RAM. I mean, this will depend on preference and more. I think I don't have a very super powerful GPU. This is for me. Maybe it's too big, but I've seen some colleagues or some of my kids' gaming friends that they have a huge. This is kind of old also, and again, it's in my perspective, in my head, but this is standard or whatever, and it works here. And I have only 16 GPU memory, so you can do something. Someone was asking about someone already have my screenshot there, but someone asking if you can run this in a, where was the question, in a 6 GB of RAM or more. I would say yes, give it a try. Maybe you don't need a big model. Maybe switch for another of the smaller Parakeet. I would say give it a try. There are some guidance around or what are your hardware needs in order to run some models, but you can give it a try, literally. You can start to play around with this and that and more and see if it really works there. For me, with this one, it works great in the sense of we can do, learn, and more. And as I said, you can even do real-time, which I am going to, it's part of the repo, real-time audio and more, but it's kind of great to do. Let me go back because we only have a couple more minutes of the questions and more. Let me go back to the chat to see if I am missing something. Okay, so a couple of questions around Copilot. Yes, I saw that someone says here that explaining that, yes, that's why we set up this instead of jumping directly to the code. I would love to start to the code, but Don and a lot of sets of very smart people also keep me honest and say, no, we need to explain where we are. We need to explain what we have. We need to explain what are the options there and then show the code. And this makes sense. It's the same. It's a very similar approach to the one that we have here when I was talking about Copilot. Remember that don't say Copilot, type this. Maybe you need to say Copilot, hey, Copilot, create a plan. When you read the plan and you agree with the plan, you say, oh, yes, there it is. Now create the code. Here I can start to change the plan and say, hey, you know what? I don't use Parakeet. I can ask questions like, in example, what about if I want to use Spanish audios? I can ask this. So I am going to iterate and explain and more. So yes, spend some time understanding, and this is hard for me because I love to code, understanding the scenarios, the code, and more, and that is. An example, Copilot here said, okay, if you want to do Spanish activities, then you have here these options. Canary 1, 1B, V2, and the Parakeet, which is not supporting there, but is the one that we have. By the way, there is a full license scenario here, which I'm not an expert, and I don't think we have enough time to talk about license here, but as far as I understand, these are free to use if you want, but read the license if you are planning to use in the production. I don't know, Don, do you know about the license of the models and more? Don't want to put you in the spot. Sorry about that.
Yeah, go learn about it, yeah.
Yes, it's like any license scenario. it's you need to learn, you need to see what you want to do, but for learning and testing and more, this is good to know stuff. Oh, sorry, more comments. Hey, that's a good question. Can you ask for Arabic? So I don't know in this one. We can ask, we can do it. We can do something like this. But early today, I was watching one of your NVIDIA. There was a video around the people doing this and retraining a specific model to be very good doing tokenization in Hebrew. And I didn't know about that. But when you pick up a standard model and you ask a sentence to be tokenized, it's literally usually 1 token per word or maybe 2 tokens per word. But in the original model, can't remember which one, when they do the tokenize, each one of the characters in the Hebrew language becomes a token, which is the model was still working, kind of. But if you think about cost, because in the cloud, tokens equals money, it wasn't very good. So they applied a couple of techniques to become better in that specific language. I'm assuming that you can do the same. You remember at the first slide when Don shared about that you have the eval kits, the agent toolkits, and you have a lot of NeMo tools to work. You can retrain a model. You can basically fine-tune one of these models to your needs. So maybe there is already one for Arabic, or you can create using one of the NeMo's synthetic data creator. I can't remember the name. Create data there, and then retrain the model for that. So hey, that's a good question. I really don't know the answer, but I'm guessing that if not there, there's a lot of tools that you can get to help there. And we are on time. Sorry about that. I don't know. Did I miss something? Did you see any question or something else that... Oh, sorry, not this one. Did you see something or something else that I missed? Sorry, I can't put my slides on. I don't know what's happened. Larissa, do you have the closing slides? My PowerPoint is there.
I don't know if you or Don want to show something else, but I'll put back Don's QR codes if you want to, Don. And about the questions, Bruno, you're good.
At this point, Bruno's been taking the questions throughout. So I just want to thank you for your time. And I sincerely hope that you feel that we did a good job in terms of laying out the concepts, giving you places to go and learn more, showed it to you in action. Now, if you start to just, come back in, maybe watch the webinar again, go and follow those links, we hope that that'll really help you do what you want to do with building AI agents quickly that do speech.
Yes. And by the way, a couple of years ago, this was magic, impossible. Now we can do this and it's super fun. So, oops, let's remove that one. So, there it is. So, hey, thanks everyone. And Larissa, I think we are done. So, see you all next one. Goodbye.
Thank you. Thank you, Bruno. Thank you, Don. Thank you all for joining us for a session today. We are always looking to improve your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link to our survey on the screen or in the chat, and we'll see you in the next